The Exercise Planning and Inject module is a support tool in the crisis system. It makes it possible to plan what will happen during an exercise as a result of time advancing, triggers going off in the virtual world, or decisions made by the instructor. The Exercise Planning and Inject module is realized by the Planner software. Actions planned and scheduled in the exercise plan using the planner are called injects. The planner supports the variable uncertainty framework developed in the crisis project. This means that a plan can be entirely deterministic to support repetitive training of part tasks, or allow random branching and variable delays between actions and consequences to challenge advanced trainees. To plan an exercise in crisis, the user needs to work both in the planner and in XVR, which is the simulation platform used in crisis. XVR maintains a three-dimensional representation of the virtual world used for training. All virtual objects used in the training exercise have to be created and configured using XVR. The planner can influence the behavior of those objects by adding injects to the exercise plan. The first step in exercise planning is to create some objects in the world. To do this, we use XVR in build mode with the BTP scenario developed in crisis. Here is a fire truck with a crew of 6, which together form a group in XVR. This group has 3 states, which indicate what the crew is doing. First, the crew is seated in the fire truck. Next, the crew exits the truck and stands outside the vehicle. Third, the crew is fighting a fire. Initially, the crew sits in the fire truck, and the fire truck is located at a position out of sight. We now want to make a plan where the truck drives up to the indicated location. Then the crew should exit the vehicle and after some briefing start fighting the fire. We now use the planner to create the injects. First, we create a move inject to move the fire truck up to the location where it should stop. We select a water tender, which is the type of the fire truck, and the target position. And then we set the trigger of this inject. We use a time trigger that will trigger after 3 minutes. Using the first inject as a base, we then create another inject, which changes the state of the fire truck. We select the fire truck and the desired state, the exit crew state, and then we set the trigger to be dependent on the arrival of the water tender. And the crew will exit after 6 seconds. We can now run the scenario in crisis to see the result. First we see the fire truck driving up to the desired target location. The crew gets off and then after some time starts fighting the fire. Injects can also change the environment. Here the user adds an inject to the plan which will cause bad weather to appear with rain and wind. To view the result, we run the scenario in crisis. Next, we're going to see how trigger objects in XVR can set off injects according to the plan. In this example, the cylinder is a trigger object. When the person enters the trigger's detection zone, smoke should appear from the yellow car. This is how to set this up in the planner. First, we create a new inject of the state change type. We type the name of the inject and a short description. Car starts to smoke when a trainee walks by. We select the big black smoke group and sets the state to smoking. The trigger is a 3D world trigger based on the danger zone world trigger, triggered by anyone walking by. We now test the scenario in crisis. Here we see the scene from the first-person view. We start walking towards the yellow car, and when we enter the trigger zone, smoke appears from the car. To make the scenario less predictable, we can introduce some variability. To do this, we'll create a minimum delay of 2 minutes and a variability interval of 5 minutes. This means that smoke will appear between 2 and 7 minutes after the person enters the triggering area. Another way to introduce variability in Crisis is to have random activation of injects. To demonstrate this, we create 3 fire and smoke objects, each with a 50% chance of being activated. We do this by setting the probability of execution to 50%. We see the 3 fire and smoke objects in the parking lot near the orange location marker. Only the middle fire and smoke object is activated. Another way to support variable uncertainty is to plan a number of injects and then let the instructor select manually what injects to use during the exercise. This was a brief presentation of the exercise planning and inject module of the Crisis system.